Hello everyone and welcome back. In the previous video we discussed the gas fee topic on the Ethereum network and in the blockchain at all. So I guess since this is a really important topic in the blockchain, we need to discuss it a bit further and do some more clarification on this topic. So I decided to show you guys a few practical examples in the code as well as on the Etherscan website as well, and see what does really make a transaction to spend more gas. So in today's topic we are going to discuss the heavy functions and the light functions. It means that the transaction fee really depends upon the complexity of the function that you are executing. So let's say a practical example of this one. Let's head over to remix.ethereum.org and create a contract in here. Heavy light, let's name it .sol. Let's specify our license, SPDX license identifier. Give it the MIT and let's specify the solidity version. We are going to use the 0.8. What's the current latest version in here? 0.8.17. 0.8.17. So let's create a contract called heavy and light functions, whatever you name it. And in here I'm going to create two functions. One function will be a light function that will include just a tiny operation of adding to an existing variable in the storage, and the next one will include some more operations, and we will compare the transaction execution cost of these two functions, and we will see that what does really the transaction cost depends on. So let's create our first function, call it light function. This is a public view return. It will return uint. Okay, so let's declare a variable in here first, a uint, name it x and give it a value of 10. So what this function will do is it will return the x value added to and add 1 to it. This is our light function. This includes a tiny operation that will add 1 to the current value of the x. We will create another function, heavy function. This will be a public view and it will not return anything. So in the heavy function, how do we include a bit more operations? So let's use a for loop here. I equal to 0, I less than 25 and I plus plus. Let's add 1 to the x every time. What's the issue here? Type error function cannot be declared as view because the expression potentially modifies the state. This is not a view, okay? So what we do in this function, we loop from 0 to 25. It means 25 times, and each time we will get the current value of the x and add 1 to it. So let's compile our contract and let's deploy it. Okay, the contract is deployed. Let's expand the terminal and call our function. So first of all, I'm going to call the light function and see how much gas it spends. Let's explore it. You can see that the execution cost for this function was 23,000 gas. In the previous video we discussed about how do we calculate the transaction fee from gas. We will do it one more time in this video as well. So you can see that for our light function it's 23,667 gas. And let's now call our heavy function. As I told you, this all depends on the amount of operation, and depending on the complexity of the function that we are calling, the transaction cost will be much more than that. So the transaction cost for this function, for our heavy function, is 40,000. The last one was, I guess, 23,000, right? And this one is 40,815 gas. So let's increase the amount of operations in our heavy function a bit more and make it 250 times. The loop will iterate this much. So let's save our contract. Zoom out, delete the current deployed contract, and when we save it, let's deploy it once again. The contract is deployed. Now let's call the light function one more time. We will see that it again spent 23,000 gas. And now let's call the heavy function. You can see that it takes much more time than the previous call, and when we explore it, you can see that it takes 173,790 gas. So my point here is that I wanted to show you guys that the amount of the transaction fee, I mean the amount of the gas fee that we spend during a transaction, it all depends on the complexity of the function. It all depends on the action that this function is doing for us. So this was a code example. I hope it was helpful. So let's explore a few live transactions on the Etherscans, which we will discuss these and see what each transaction cost. The first transaction that we are going to see here is ETH transfer or Ether transfer transaction. It's amount of 70 Ether. You can see that it spent 21,000 gas, and the gas price is 20 GUI right now in this transaction. Then the amount of the transaction fee that it spent is $0.72. This is a simple Ether transaction. I mean, the cheapest transaction on the Ethereum network is transferring Ether from one account to another account, or from one contract to another contract. Next one, we will see another transaction. The transaction action right here is, I guess it is a transfer of not Ether. This is a transfer of USDT or another stable coin on the Ethereum network. This costs much more than transferring the Ether, which is the native currency of the Ethereum network. You can see that the amount of gas used by this transaction, which is a transfer of USDT from one account to another account, it has used 63,000 gas, and the 63,000 gas, and the gas price at this time was 63.55 GUI. So you can see that the transaction fee for transferring one coin from one account to another account, which is not the native currency of the Ethereum, will cost much more than the Ethereum or Ether. Sorry about that. The next one that you are going to see in here is it's a transaction of selling one NFT on the OpenSea platform. You can see that the NFT or the token is transferred from one account to another account. You can see that the amount of gas used by this transaction is 140,691 GUI, of course, amount of gas, and the price of it's much lower, and you can see that the transaction fee for this transaction or the gas fee for this transaction is $2.07. So you can see that the different transactions, depending on the type of the transaction, the complexity of the function that we are calling, we are spending different amounts of gas. The next transaction that we can see in here is a transfer of one token of NFT from one account to another account. You can see that in here the amount of gas that we spent is 82,000, and the gas price was 25 GUI at this time. So you can see that it has costed $3.63 for this transaction. The next transaction is here. I guess it's a swap on the Uniswap platform. They have swapped one coin for another, and this is, I guess, the most expensive transaction that we have seen so far. I mean, among these transactions, there may be more expensive than this as well. So you can see the amount of gas this transaction has spent is 129,000. And the gas price is 64,000. So the formula that we discussed at the previous video for calculating the gas fee for a transaction was like this, I guess. Let's remove this stuff. So the formula was like this: the transaction fee is equals to the gas used by the transaction times the gas price. This will give us the gas price in GUE. So since 1 Ethereum is equal to 1 billion GUE, we should divide it by 1 billion. And if you want to get the price of this transaction in dollars, we should divide it by the Ether price. So this was how we used to calculate the transaction fee. Let's calculate this one. The amount of gas used by this transaction is this one, 129,000. We should multiply this one by the exact price of the gas. This is the gas price right now. Let's multiply it. So this is the amount that we currently have. This is in GUE, of course. We should divide it by 1 billion. Okay, we get this price. And now to get the this is in ethers. To get the transaction execution cost in Ethereum, I mean in USD, we should see what the exact price of Ether is on the CoinMarketCap or any other platform that you're using. 1708.30. So we should multiply it now by 708.30. So this is $14. We can see that this is the amount that we have in here, $14.17. So this differs a bit with the amount that we just calculated in here. This is roughly because of the fluctuation that we can see on at the Ethereum price in here. The Ethereum price is going up and down, and this way the amount of the gas price or the gas spent or the transaction execution cost will differ at the different times. But we can see that we got almost the exact amount spent for this transaction using our formula, and you guys can use it as well. This is the formula you can always use for calculating the transaction fee. So I guess this is it for this video. I will see you guys in the next one. Have a great day.